but because I was out for most of the week, like I had to make up the time for studying and whatnot. But yeah, hopefully I'm all caught up by now.
I'm sorry. That's no good.
Yeah, but I'm feeling better, yeah, now. So a
Okay.
little brain addled, but
Well, sounds good. All right. Should we start?
yes. Do you want to say the prayer?
Yeah, I was gonna say, is it me?
Okay.
Our Father in heaven, we're grateful that we can complete this math assignment. We ask that we all may be able to feel better health-wise, that we may be able to feel that we can be able to go about our day and do the things that we need. We ask that we'll be able to do well in this math assignment and that we'll be able to do all that God wants us to. My lovely Father, and we say this in the name of Jesus Christ. Amen.
And then we go ahead and do screen share. Okay, cool. So just to begin with the um, GHOA thing. Okay, so he wants us to begin by discussing what a vector is, discuss how to find the component form, given the magnitude and direction, and how to do the vector operations of addition, subtraction, scalar multiplication, dot product, and angle between two vectors. So basically talk about vectors. Did you have any problems um, with learning about vectors?
No, I think it's good,
Okay,
honestly.
yeah, I thought so too. Um,
I feel like this is some of the easiest stuff. Easier.
yeah. I'm not gonna lie, I had a little bit of confusion with like converting the like one function to another, but
Uh-huh.
that's later in this assignment. Um, so you discuss what a polar coordinate is and how to plot the polar coordinate. Discuss your solution for converting between Cartesian and polar and vice versa. Okay. So plotting the polar coordinates, wasn't that just like um, so you have like your graph and then the first number is the radius and the second number is the degrees, right?
Yeah, I think so.
Okay. Um, then for converting between Cartesian and polar, there was just the couple equations they gave us um, that we were supposed to use. Mm.
I'm just pulling. Sorry, I'm just pulling it up.
Okay.
Do you want to hold on?
Yeah, let's go ahead and move on. Ensure that each team member is able to develop the formulas for converting found in question number 6 of the preparation. So, what he's talking about, they actually went over in the videos. So
Uh-huh.
I'm fine with that. That
I'm honestly like ready to just
get into
jump right
plots.
into the extension problems.
Okay. All right. So, given two vectors, how would you find the resultant vector? Draw two vectors and the resultant vector. Um,
Isn't it just like you draw an angle? Oh, I can pull up what you're doing. That would help, huh? Yeah, literally that.
okay. Cool. Yeah, while I was waiting, I went ahead and I copied over the definition just for my sake and sanity. Um,
Yeah, I was
yeah,
looking over it too. That's why I was like, I was working and then I ran out of time and I was like, I better look at this a little bit because I looked at it. I looked at it a while ago, but I
yeah.
haven't looked at it today all or yesterday. so it's been
Okay.
a few days, but I didn't have any troubles
Okay.
when we went over it. So
Okay, cool. Um, so imagine the following scenario. Um, okay, it gives us a lot of history. Um, Imagine that the two horses have an angle of 65 degrees between them. One horse is pulling at a force of 200 pounds, and the other is pulling at a force of 300 pounds. The force would be the magnitude of a vector. What is the magnitude of the resultant force? What is the angle between each horse and the resultant force? Um, so they went over a problem that was basically this, except without all the backstory in the videos as well.
yeah, I remember that, and it literally gave it was like the exact same problem.
Yeah. Okay, cool. Okay, so
So from the stump, one goes 200, and one side is 300.
yeah. Oh, no, I don't. So confused with that. Okay. Okay. You have the angle of 65 degrees. And then, so the way that they did it was, let me see, so you have 180 minus 160, not 165, minus 65 um, will give us angle on the other side, which is the same as um, what we usually call, well, not usually call, what is this called? I don't know, one of the angles in the triangle. That is 115.
Right.
And my tablet is doing something really funky. Okay, and then because we have this two sides in an angle, um, we use the side angle side.
Mm-hmm.
So that would be 200 squared plus, don't know why this is lagging so bad.
You don't what?
My software is kind of lagging for some reason. I'm just gonna go ahead
Weird.
and scroll. Yeah, it should be fine now. There you go. Maybe not. Anyway, so if you use the cosine formula, it should give you that B is equal to 425.1. Did you say that you're not feeling well either?
Um, it's just been going around. Like my husband is homesick today. He didn't go to school.
Oh no, I'm sorry.
That's okay. He's fine. He'll be all good. I think it's just going around.
Yeah.
Is it still
Sorry.
snowy where you are?
No, it's early spring now, so it's a little chilly, but it's nice. But I think you're right because like my brother was sick and my dad was sick, and now I'm sick.
I'm
So
sorry.
it might just be the time of year.
I think it is, honestly. I think it's just like, I just feel kind of like, I don't really have like a cough super bad, but kind of just like sinus stuff just a little bit, but not bad. So
Yeah, that's good.
sounds like you've been pretty sick. So
Oh, I exaggerate. um, I
Yeah,
don't
that's what
know.
I got for the middle line. I got 425.1. And that's what you got as well, right?
Yep.
Okay.
Then if we want to find the other angle, which we can
Mhm.
call A.
Use. Are you just gonna do sine of 115?
Yeah.
Okay. And then sine of whatever over 200?
Yeah.
Okay. Oh, you already have it written down. I was looking down. Sorry.
No worries.
I'm just figuring it out on the calculator.
Okay.
Okay, I got 25.239.
Yep, that's what I got.
Awesome.
Okay. Do we need to find the other angle, or is that fine?
I think, I mean, we can.
Yeah, it's kind of no-brainer. Yeah, it's probably fine. Going on to the next one. Oh yeah, this is the one that I had a bit of a problem with. Um, so we need to convert the following equations, and he gives us three.
I think it's already telling you that we already did do this.
Well, yeah, he gives us like, yeah, he
Oh,
kind of walks
okay,
us
I
through
see.
steps. Yeah. Okay. So first one he wants us to do is negative 3x minus 2. So I went ahead and tried to do these. And like I looked at the solutions that he gave, and I couldn't for the life of me figure out how he did it. Um, like, okay, so the first one, 3x minus 2, is supposed to be converted into um, r equals negative 2 over sine theta minus cosine theta.
Okay, so we know that y is equal to cosine, right? No, sine.
Yeah, it's equal to r sine theta. Um,
I'm gonna write this down really quick. Hold on 1 second.
okay.
Yeah, these ones, like, some of them are super easy and you like catch on really quick, and the others are like,
Yeah. Like I was fine with the middle one, but the other two I had problems with.
So I
Um,
think what we should do, oh, I think, so for y, you just replace r sine of theta equals 3 r cosine theta. minus 2.
Okay, one sec. Oh, there's supposed to be an R in there. And R cosine theta minus 2. And then we just do, wait,
And then we could,
do we add 3R cosine theta to R sine theta? Like,
my thing is like, how do you get rid of the 3?
I don't know.
You know what I mean?
Yeah.
Um,
Because the way that I was doing it was, and this isn't quite right because obviously I didn't get what he got. Let me see. So I brought over,
the negative 3x, that's what I'm
yeah,
thinking we need to do too.
and then that was still negative 2. Yeah, and then I made this R sine theta, come on, there we go, minus 3R cosine theta. So once again, like there's a 3 there, and you could say that there's a 1 before sine or whatnot,
Right.
but
But it,
1 before R.
yeah, I just don't know how you get rid of the 3.
Yeah, because either way, it'd be like, even if we did 1 minus negative 3, it'd be negative 2. Oh, 1 minus 3 is negative 2. Oh no.
Okay. So, I don't know how he got rid of the 3. I don't feel like there's a way to get rid of it.
Yeah. If we try to solve
Because
without,
I just Googled it. I said polar equation and I typed it in.
yeah,
And it gave us 2 divided by sine theta of negative cosine theta. So it left the 3 in there.
okay.
And that's the answer they gave. I'm just looking to see if they're. Hmm. Could you square both? No. How do you like?
Um,
I don't know how you get rid of the 3.
yeah. Okay.
Maybe
This
let's
is,
do the next one and then come back.
yeah, sure. That one's easier.
Yeah, well,
Okay.
this one's not too hard at all, actually.
No. So for this one, we would just, oh, come on.
For this one, you know that x squared plus y squared equals r squared, so you just replace that.
Yeah. So,
You'd have r squared equals 9.
yeah.
And then I just took the square root, so it's plus or minus 3. R equals plus or minus 3.
Yeah. Cool.
Okay, that one isn't too bad.
How was that? Okay. Um, then for the last one, I also had a problem with this one. I think I got closer though. So we have r equals 3 over 1 minus cosine theta. No, maybe I didn't get closer at all. What he wants us to turn it into is x equals y squared over 6 minus 3 halves.
Doesn't 1 minus cosine equal something?
Um, I don't know. I don't think so. At least not according to what he gave us.
Mm-hmm.
One second. I'm just gonna look at the formulas again. Yeah. Um. Because if we do, okay, if we times both sides by r,
Mm-hmm. Then you'd have r squared.
yeah, you'd have r squared, and then would that make it 3r? And then, no, wait, would make it 3r. Actually, what if we do times both sides by 1 over r? I don't know if this is how you do it. I think I might be wrong here. Um, I am.
Because I know that cosines, well, that's not squared.
I feel like that's wrong. Um, if we times something by 1 over r, does it affect the denominator? Or I am doing something wrong? Okay.
Because somehow you have to bring, is cosine, somehow you have to bring in y.
Yeah, and cosine becomes y.
Yeah, well, cosine normally becomes x, right?
Oh, yeah, you're right. Sorry.
So we have to figure out a way that we can get cosine into y or r into y because the answer doesn't have any x values.
Yeah. Um, yeah, that's weird. I can't remember how I did it before. Um, okay, because you can't turn r into, yeah, r is equal to the square root of x squared plus y squared. Yeah, so we could
So
do,
would r also be equal r equals x plus y?
um, oh, I don't think so.
I don't know. I was wondering.
I know that r squared is equal to x squared plus y squared. That's how that works.
Okay.
But, so if we do set r to be x, oh, jeez, x squared plus y squared is equal to, actually, I feel like we should take care of cosine first. So if we just multiply both sides by 1 minus cosine theta, we'd end up with r minus r cosine theta equals 3. See, this would become What's the name of this? Um, okay. Okay. Our cosine theta would become x equals 3, and then we could turn r into the square root of x squared plus y squared is equal to, well, minus x is equal to 3. Um,
You could add the x over.
yeah,
I'm just trying to. I feel like you have to like do these problems and then erase them a billion times because I.
yeah. Kind of a mess. Then if you were to do x squared plus y squared, and this would become 9 plus x squared. This still isn't feeling right because in the end you would end up with y squared equals 9. And you get y equals 3. Okay. Hmm.
Because you have to keep the y squared.
Yeah. Something went wrong at some point.
Clicking on the notes.
Okay.
I'm looking at his video for polar coordinates.
Okay. I think I'm getting somewhere. Yeah, I think I got it.
Did you?
Yeah, I think so. So
I think
we
you
have,
did.
yeah. I was just messing around. So what you do is that you times both sides by cosine. Our cosine becomes x. Then you bring r back over to the right side, and it becomes the x squared plus y squared uh, under square root. Then you minus both sides by x squared, which makes the left side become negative 2 times x squared. Divide both sides by 2. We still have negative x squared equals y squared over 2 plus 3 over 2. If you multiply both sides by negative 1, get negative y squared. Should be right.
Yours like really close though.
Yeah. um, yeah, because I think if you multiply both sides by negative 1, then you switch the operators and it becomes positive and negative. It's kind of messy.
Sometimes I look at this math and I think, man, this is so pointless.
Like, why do we need to know this? I'm sure there's a reason. I'm lost right now.
Because then, well,
Wait, why? Okay, I guess if I do times -1, this is still positive.
I'm just looking at your negative 2x squared. Because if you times the other side by 2, like, see how you have negative 2x squared equals y squared plus 3?
Yeah.
If you somehow, where did you get the negative 2 from on that side?
So I got that because let's see, what did I do? I subtracted negative x squared from both sides.
Uh-huh.
And so that gave, oh, stop that. And so this is basically, we put a 1 in front of both, and that, so it becomes negative 2x squared.
Oh, okay. That makes sense. Because I'm just wondering, so the answer is y squared over 6 minus 3 over 2,
Oh, okay.
which is also equal to y squared minus 9 over 3. So in your end problem, instead of dividing by 2, if you were to multiply by 2, you would get that, I think.
Okay.
Or maybe not.
Yeah.
Well, maybe not, because you'd have to divide by 2.
Yeah.
It has to be 6. Oh, this is
Okay.
frustrating me.
I know. Okay. Let me go ahead and hold on to that because I think there's something in that. But we rewrite the problem out again. With r equals, because I'm sure it's just something really stupid that I'm not doing right.
Well,
Okay. So if we do what we did last time and multiply both sides by 1 minus cosine of theta, then distribute that, and that'd be r minus r cosine. Because I feel like this much is right, that you can turn r minus x equals 3. Um, I wonder if you squared everything, what would happen? Because that would leave you with, well, first bring r over to the other side. Mm. Oh wait. I did it again.
I don't even know.
Mm.
I have got like nothing on these two.
Yeah. Um. I don't even know where to look.
That's how I am. I'm like,
Okay. Because so I know that the equation that we have to convert on the quiz isn't as hard as the first and the third one of these for some reason.
no,
Um,
I've looked at the quiz too, and I went through it. Do you just want to start on the quiz?
yeah, let's go ahead and do that.
Because the quiz, I actually think I know pretty well.
Yeah, it's not bad. Just open up another GIMP.
Let's just start on the quiz.
Okay.
I say, I don't know about those other two. Whew.
Okay, so question number 1 is a quiz. It is, oh, it's the river one. So
Yeah.
I think I did this one right, but so if you, because you've already gone through this before.
Yeah. Do you want me to show you what I did?
Sure.
Okay. So, I don't know if you can see this. Can you
Yeah, I
see
can see it.
that?
Yep.
So, yeah, I just drew out the triangle with 6.2 on one side and 3 on the other, and then
Okay.
set it up like that. Oh, maybe I'll go back a little bit.
Okay, so you used tangent instead of um. Okay,
Mm-hmm.
so you did it a little bit differently than I did. I'm trying to see if we got the same answer. I think we did, which is confusing, but it's all good. um, yeah, okay, cool.
And then just make sure to put on the 64.179, just make sure to put northwest because that's the direction as well.
Oh, yeah, that makes sense. It's funny because you used tangent, and I went ahead and used the sine thing with like the sine angle over side.
Mm-hmm.
Um, the tangent would have been easier. That was cool. Okay,
Yeah, I just did the inverse tangent of it.
awesome.
So, I don't know. I can go through the other ones too. Have you already done them all?
Um, yes, like I've gone through them. I don't know if I got them right.
Okay, well, I kind of have gone through them too.
Okay,
I'll run through it really quick right now. Let's just do the second one. The second one's not too hard at all.
yeah. Okay. Write the equivalent rectangular equation for the polar equation. Okay. So that one was, let me see. So we have r equals 10 over, can't draw straight lines, 3 sine of theta. Oh my gosh, this is lagging. Okay. I multiplied both sides by 1 over r. So we got left with 1 equals 10.
Are you writing on the board again?
Yeah,
No, I can't see it now anymore.
sorry. What? Really?
No.
Did I turn off screen share? Oh my goodness, I'm just talking at you. Okay, there you go. You see it now?
You were just looking very intently, and I couldn't tell if you had it on or not.
I just am really good at that must be really awkward. I'm sorry.
Fine, okay.
Yeah, okay. So see our sine theta. Come on. This program is lagging so much. Okay, so
Where
our
you? Sorry, 1 second. Where are you going? Will you come back here though? In between? I don't know. I'm just calling to get my haircut. All right.
okay, so our sine theta becomes y, and then 7 cosine theta becomes x, and then you divide that over. Well, you times it over, so you get 3y minus 7x equals 10. That's what I got.
Yeah, I did it in a little bit different way, but I think you can do these problems in like all sorts of ways.
Yeah.
Because I got the same thing as you.
Really? Oh
Yeah. Uh-huh.
That's funny.
1 second and I'll show you. Okay. So this is like the worst. Let me hold on 1 second so I can see what I'm showing you. Okay. That's that problem. Wait, can you see the whole thing?
I can kind of see it. Let's see. I can't really see the left side as well. Sorry. I'm trying to figure out the
Maybe I'll
camera
just
from my
take, I'm just going to take a picture of it
Okay, cool.
and I'll text it to you. So what I did is I times 3 sine theta minus 7 cosine theta by r.
Okay.
And then I just did it like that. I'll take a picture of it really quick. I think we got the exact same answer, so
That's a good sign.
I don't think it matters.
Okay, so for the next problem, there's another converting equations. So it was, oh dang, where did it go? Yeah, so x squared plus y squared equals 9. Okay, so that would just be,
R squared.
yeah. Okay. So the way I did it was just to turn it into r. See, I square rooted both to get rid of the square over the xy.
That's literally what I just did. Yep.
Hey, awesome.
So then you have R equals, yep.
And then x over y becomes tangent.
Uh-huh. Except for on the 9, because you're taking the square root of 9, I think it would be 3.
Yeah. That is so right, yeah.
But yeah, that's exactly what I did.
Cool. Okay. Then the last one I thought was super simple. So we just had to plot out the polar coordinate. Okay, let me see if I can draw a circle. There we go. So the polar coordinate we got was 4, and then 4 pi over 3.
So we know that our magnitude is going to be 4.
Yeah.
And then 4 pi over 3 is 240 degrees.
Okay. So that would be like about there.
Mm-hmm.
Okay. And then he wants us to also put down 2 other ones. And by my understanding, the way that you can like see the other points that could be on the same graph, you can look at making it -4 and then pi over 3, because pi over 3 is what is over here.
Mm-hmm.
And then 4 and -2 pi over 3, because 2 pi over 3 is the one that's right here on this side. So it'd be kind of like inverted.
I agree.
Okay. Cool.
How many points do we need?
Just 2 other points.
Just 2 other. Can we just write them in that same way, like 2 pi over, do we have to solve them?
No, I think we just have to do that.
Okay, that's fine with me.
Let me see. Yeah, he says just name 2 other polar coordinates that are located in the same place. Okay, so that's the quiz. I don't
Okay.
know.
So, can I see what you put on that last one again?
Oh yeah.
Just to make sure I'm understanding it right. You put -4 pi 3. And then we had 4, 2 pi over 3. And then we needed, what were the other ones you put?
-4 and pi over 3, and then 4, -2 pi over 3.
Do we need one more or just 2?
We just needed 2.
Oh, okay. Then I'm good with that.
Cool.
The quiz wasn't bad.
No, it wasn't. It's all good. Do you want to go back and try to convert the other equations, or do you just want to be done with this?
I'm fine with being done, but I mean, if you want to go back, then we can try. But I know you're not feeling good, so it's up to you.
Yeah, honestly. I think I'll go ahead and like try to fiddle around with the equations a little more and see if I can figure it out. And if I do, I'll go ahead and send you what I figured out. But aside from that, I think we can go ahead and leave it off here.
Sounds good to me. Thank you very much. That was awesome.
Yeah, thank you.
I hope you get feeling better.
Thank you. I hope you and your husband feel better as well.
He's doing fine. He's like a baby. I shouldn't say that.
Okay, well, I'll see you next week.
Okay, see ya. Bye.
Bye.